Welcome back to more math with Miss Wimmer. Oh, what fun! Today's learning target. I can calculate greatest common factor. You need a lot of room to write, so don't write very big on this. Greatest common factor. Oh, factor. I've heard that a couple days now. Also known as the greatest common divisor. Because if you think about it, what are some factors of 12? 1 and 12, 2 and 6, 3 and 4. Those are also things that divide 12 equally. So when you see greatest common divisor with a D, you don't have to be worried of, I don't know what I'm doing. Yes, you do. Divisor and factor, the same thing. The biggest factor that is the same for two or more numbers you've talked about in 6th grade for sure. And now that we're in 7th grade, expressions, which means dun, da, 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 variables. Oh boy. So we actually have two strategies that we can use for this. We can solve by listing the factor pairs, or doing the prime factorizations. Hey, we practiced that last time. We would be using the trees. Do you need to pause right now? Also, you should still be writing. This is a big one. Just when you think you don't have any common factors, then you know the greatest common factor is 1. For example, if you think 12 and 37, remember 37 was a prime one from the other day? It looks like they don't have anything in common, which means their greatest common factor is 1. So I actually just did the first strategy, which is making factor pairs. But you have some examples on your notes too in the next boxes. Did you need to write anything down? Do you need to pause again? Okay, so these first two, if you notice on your notes, it says make a list. So let's make a list of these factors. So we can find the greatest common factor. Now would be a really good time to pause and list some factors. Okay, for 8, I have 1 and 8, 2 and 4. What am I missing? 3? Nope, no 3. For 20, I have 1 and 20, 2 and 10, 3, nope, 4 and 5. Okay, now I'm looking for the greatest one they have in common. Well, they both have a 1. They both have a 2. They both have a 4. Oh, that's it, I guess. Greatest common factor of 8 and 20 is 4. 12. Oh, that one keeps coming up for me today. It must be my favorite number today. 1 and 12, 2 and 6, 3 and 4, 87. Is that prime? It's odd, so 2 isn't going to work. Will 3 work? Oh, hey, remember that divisibility rule? 8 plus 7 is 15. If you can divide 15 by 3, then you can divide 87 by 3. So 3 and... oh, side problem it is. Three and 29. Okay, now here's a little trick. I'm looking at my choices and I can use my 12 to help me. So we have 1, 2 didn't work. We have 3, 4. Could I put a 4 here? Oh, no. As soon as I have to add a decimal, then it's not divisible. I can for sure divide it, but it's not divisible. Okay, can I put a 6 here? Oh, can't do it because I added that decimal. I could get a decimal answer, but I only want whole numbers for this. Last one, could I put a 12 there? 12, 24, 36, 48, 60, 72, 84. Nope. Okay, so I used my 12 factors to help me. And that's not going to be any of the options right here. So I just found out that the greatest common factor is 3. Back up here for a moment. Okay, solve by listing the factor pairs. That's what I was just doing. Now I'm going to try 2 of them under the list, or the prime factorization. So I would need a tree for 12, a tree for 8, a tree for 15, a tree for 45. Go ahead, pause, make your trees. Remember, your tree might look different than my tree, and that's okay. So for 12, I have 2 times 2 times 3. And then look over here. R, R, R. Kind of sounds like a pirate. R. I'm going to switch to another color. for 8. 2 times 2 times 2, and then look, R. Okay, now I'm looking for the things that they have in common. So I see a 2 that they have in common. I see another 2 that they have in common. And I see an R that they have in common. R. You know what that means? The greatest common factor is 4R. Normally people say, well, how'd you get 4? Well, right here. 2 times 2, 4. So, when there are variables, you don't have to panic. You just have to treat them like they're numbers and find what they have in common. Ready for 15? Oh, that wasn't bad. 3 times 5. No pirates here. 45. Oh, let's see. 9 and 5. Oh, I like when they're accidentally in order like that. Okay, then I ask myself again, what do they have in common? I see a 3 in common. I see a 5 in common. I see an M in common. 3 times 5 times M. GCF 15M. Where did we get the 15? Oh, 3 times 5 was 15. Also, let's just say that this had another M with it. I can circle 2 M's. How do I write 2 M's? Oh, M squared. We've already been practicing that. So whatever they have in common goes into my little greatest common factor down here. But I noticed I could put 3 times 5 together for 15. So when I look at your papers that you're going to turn in, you either have lists of factor pairs, or you have trees with prime numbers. And I should see you, circling things that they have in common. I should see you circling things they have in common. So when people turn in a page that says this, I know you're not actually solving, because you have to have work. How will you get work? You will write it down. Factor trees or factor pairs. Those are your choices. That means your page is probably going to fill up pretty fast. Again, one more time, for the trees, you find everything they have in common for your greatest common factor. Everything they have in common. Everything they have in common. Everything they have in common. Why are the 3 and the 2 not circled right here? They don't have that in common, so I can't put that down below for my greatest common factor. If you need to rewind and watch again, you go right ahead. That is called learning, people. Greatest common factor.